USD Native has arrived inside Katana 7, and I'm really excited to be taking you through these new features. Katana's USD journey began many releases ago with the ability to ingest an entire stage, converting it to allow you to manipulate that data inside Katana, as well as USD material and light creation and export. This release begins the next phase of USD in Katana, bringing you brand new workflows for stage building and manipulation. So you can work with USD data natively inside Katana with no need for conversion. The way this has been introduced allows you to work with a combination of both native USD workflows and all the traditional Katana workflows and features that you know and love. So you'll still get all the benefits of multi-shot workflows, Foresight Plus, deferred loading, Nuke Bridge, and so on, as well as all the speed and flexibility that come with USD. So you really do get the best of both. So let's jump into Katana and take a look at what's new. First of all, we have a new tab, the Scene Explorer tab, which encompasses the Katana scene graph as well as the brand new USD scene graph. The scene graph tab is still available as well if you want to continue using it, but the Scene Explorer has been designed to be a long-term replacement, and you'll find it more performant on the Katana side. You can choose to view just USD or Katana or both, so you can use this instead of the scene graph even if you're not yet working with USD. You may have noticed the UI has been updated for the working sets as well to make these a little clearer, and on the USD side we've added a couple of new working sets for loading payloads and activating prims. I'll go through these in a bit more detail later in the video. As well as the Scene Explorer, we also introduced a collection of new nodes for working with USD natively. These can be accessed from the USD Nodes menu, or as usual from the tab Node Creation menu. All the native nodes will start with a USD prefix and are coloured blue by default, so you can really easily distinguish between them and the native Katana nodes. The USD nodes from pre-Katana 7 will all start with USD in, the same as they did before, and these workflows are all still completely valid and supported in Katana 7. With these new nodes, you can build USD stages using composition arcs and then manipulate that USD data with any transformations, editing the attributes, relationships, or metadata, or even bringing certain elements into native Katana to continue making edits using Katana nodes. For example, if you have a composed USD stage exported from another application, which includes geometry, materials, cameras, and lights, for example, then this can be brought in through the USD sublayer add node, and everything will come through into the scene. You'll then be able to use the native USD nodes to make any edits, or bring elements over to Katana side where needed, and continue making edits and tweaks whilst working natively in USD as well as Katana. To compare, let's look at the same USD stage using the USD in node, which is the pre-Katana 7 tool for bringing in USD data. You can see we have all the same elements, still all of the geometry, materials, cameras, and so on are all imported and converted to Katana locations and attributes. And if I merge both of these together, because we can merge USD elements with Katana elements, then we have both of these visible within the same scene. So you can actually work with a combination of all of these nodes. So all the Scene Explorer locations here can be manipulated with Katana nodes, and all the USD locations must be manipulated with the new USD nodes. Because the USD in method involves this conversion to Katana, and USD sublayer add doesn't, you'll likely notice some speed improvements when loading this in and in the viewer when using USD sublayer add. Having said this, I do want to reiterate that USD in is still a very valid workflow and a good option in a lot of cases. It really just depends on your specific needs, whichever you choose to use. If I open up the Attributes tab, we can select a mesh on the USD side or the Katana side and see the attributes for both of these all in one place. So with the USD mesh selected, we can see the attributes and relationships, including the material bindings. And the same, if I switch over to the same mesh on the Katana side, we can see all of these attributes, and the binding has been converted over to a material assignment. So let's have a look at a more complex example. As well as being able to bring in an entire stage natively, we can also build up that stage inside Katana. As I'm building up this scene, I'll refer to the USD glossary documentation when talking about USD specific terms. This is a really great resource to find out more about any USD concepts, and because a lot of the workflows I'll be following relate to native USD rather than Katana, there's a huge amount of information online in this glossary and elsewhere, as well as inside the Katana documentation. So the first thing I'm going to do is set up the structure for my scene hierarchy by creating prims for each element that I'll be bringing in. This is necessary because when I import the scene elements, they'll need to be loaded to prim paths that are already defined. Otherwise, they'll be created with over specifiers and therefore won't be included in the stage traversal. The USD prim create node can be used to create these locations. Using this node, you can choose from a lot of different prim types like planes, cubes, cameras, or shaders if you want. This list is dynamic, meaning that it will be populated by querying your USD version. For defining the hierarchy, I can just leave this blank as it was set to by default, and I'll just add the paths that I want to create. I'm going to jump into the file structure for this asset for a sec, just to give an idea of what these paths I'm creating are for. So for this particular asset, I have a sequence of 5 shots. And at the moment, I'm going to focus on the sequence files as I only want to be setting up the hierarchy for the sequence level at this point. Everything else will be done for each individual shot. So the environment is built up of just 4 parts, which are duplicated and positioned to build up this full set. So we have the doors and the hallway sections, and we have just one character payload, which again is duplicated multiple times. And the same if I jump into the props. So the same for this gun prop. And then I have a turret prop. So the way I'm going to structure this is to bring in each asset's payload into a location and then reference in the look. Then I can inherit or specialize from that location to each other location that's needed, so that I can then reference the relevant layout or animation. By doing this, I'm really breaking down what would likely already be included in a USD file, but I want to show how these steps can also be carried out natively inside of Katana. So let's jump back into Katana and I can start getting this all set up. First, I want to set up the locations for the different aspects of the scene. The payloads will be loaded under these locations, so I'm going to use the class specifier because classes won't be included in stage traversals, but can still be inherited from. And it's the inherited locations that I'll want to be included. So I'll enter the paths for these. I'm using an underscore before each location that I add. This is a Pixar naming convention for classes, and it makes it really easy to identify them in the Scene Explorer. But you can use your own naming conventions here as well. And I'm just going to add one path for the environment, the props, and the characters. Once I've done that, you'll see that we don't yet have anything in the Scene Explorer. And that's because we need to enable this prim spec hierarchy option. When it's disabled, you can see in the tooltip here, all but the final prim will be set with over specifiers, which isn't what I want in this case. I need all the locations to be set as classes. So when I enable it, we can see those locations that I've created over in the Scene Explorer. Then I want to add some defined locations under these classes, which will be the locations where each payload is loaded to. So I can use another prim create and grab the class locations. Then just add another prim for each asset. So I have my hallway section, and intersection, the 2 door versions. I have my gun and turret props, and my character. And these I want to leave as defines because I want them to be defined underneath the classes. And I'm going to leave the primspec hierarchy option unchecked because if I check this, then my classes will be overwritten as defines, and that's not what I want. I want these locations to be classes and these to be defines. So now I should be able to see all these locations over in the Scene Explorer. At the moment, they won't be included in the scene traversal because they are children of classes, but when I come to inherit from these locations, I'll be inheriting a defined prim, not a class. This will probably make a bit more sense when I start loading in the assets. So let's do that now. I want to load in my payloads to these locations and then reference in the look. I'm just going to jump back to the file browser for a second to show. So you can see I have my payload USD file and then a look file as well. And I have these for each asset. Depending on how you exported your USD data, you may also have an assembly file like I do here, which if we open this up, you can see it appends the payload and look as a reference within the file. So I could just bring in this assembly file and that might be a preferred workflow for you. I'm going to demonstrate both methods. So first of all, I'll use a USD payload set node to load a payload in. This node is pretty self-explanatory. It lets you load in an asset using the payload composition arc. It's common practice to use payloads for each asset as opposed to other composition arcs because payloads have the added benefit of the option to be loaded or unloaded. This loading can be controlled using the payload working set. I'll demonstrate this a little later when we have more of the scene set up. So I'm going to start with just one of these assets just so the workflow is really clear, and it will be the same workflow repeated for each asset anyway. So we can middle mouse click and drag in the usual way to grab a location and input the prim path to load to. Then I'll navigate to the payload USD file and I can set this to a relative expression in the usual way. I'm just going to save this scene first so that I can use the project directory inside this expression. Now I have my payload loaded under this location. If I expand this out, we can see that here in the Scene Explorer, but nothing in the viewer yet, which is expected because it's loaded underneath a class. If I jump back to my definitions and enable that primspec hierarchy, then we will see the geometry because the classes are being overwritten as defines. So now these locations are being included in the stage traversal. Just to demonstrate, now if I enable the payload working set, you can see that it's no longer loaded because I need to manually choose which payloads to load. In a similar way to the viewer or render visibility working sets that you may be used to. Again, we'll dive into this in a bit more detail once the scene is set up. And I'll make sure to turn that checkbox off again. Next, I want to bring in the look file as a reference to the same location. And I'll use a USD reference set. Again, this node is just allowing me to bring in the look file layer as a reference. And here I can drag the location over and navigate to the look file. And now we should see our materials loaded in as well. So if we find them in the Scene Explorer, there we are under root materials location. I can see all the materials that have been brought in through this USD look file. And we can also check that the material bindings have come through correctly as well using the attributes tab. So if I click on any of the meshes and open up this tab, we can see the attributes as well as any relationships, including the material bindings. And these have all come through because they're baked out with the look files. As we can see, if I open up the look file here, you can see all the bindings are contained within it. If you wanted to edit this binding or another relationship, you can use a USD relationship set node or a USD attribute set node for editing the attributes. And these work in exactly the same way as the Katana attribute set, where you can drag a location across, enter the attribute or relationship name that you want to edit, and give it a new value. So in this case, I could find another material in the scene, like this glass material that we have, drag it over, and then this will update in the relationships. Let me just open the tab over here so we can see a bit better. So if I disable and enable this node, then you can see the material binding updating. With the Attributes tab, you also have the extra options for choosing the action, so how you want it to affect the attribute, as well as the type, which can be chosen from the dropdown. An example of this could be to set the visibility of a prim to invisible. To demonstrate this, I'll just switch the prim spec hierarchy on again, and now we'll be able to see that asset in the viewer as before. But if I change the visibility, which is a token, to invisible, then this geometry will no longer be visible in the viewer. And we can also see that reflected in the Attributes tab as well. So this is just a couple of quick examples as to how you can use these nodes. I'm going to delete them as they're not needed for our scene setup. And I'll switch the prim spec hierarchy off again. Just to compare, I'm going to bring the assembly file in instead of the payload in Look, just to show you that alternative workflow. So I'll use a reference again to bring in the assembly. And you can see that we get the exact same result as before. The payload is brought in and the look is referenced with the material bindings, which we can confirm in the attributes. The only difference is that this prim kind is an assembly as opposed to a component. And because the kind is metadata on these prims, we could actually edit this metadata and change the kind from assembly to component or vice versa using a USD metadata set. So I can drag this path over, and you'll see as soon as I enter the metadata name kind in here, it is a token, so the kind will disappear from the Scene Explorer until we add another value. And you'll also see that the icon used to symbolize these different kinds will update as well. So if I put component as the value, then we can see the symbol update to indicate it's a component. And the same if I put group or subcomponent. So we get this nice visual indication. Again, this is just one example of how the USD metadata set node can be used. You can really edit or add any metadata in the same way that you can edit the attributes and relationships. I'll just delete these for now because I was just adding them as a demonstration. Again, this may be a preferred workflow for you to use assembly files. Both of these are completely valid, but I'm going to be splitting it out and working with payload and reference sets separately. And now I can repeat this process for all the payloads that I need to load in the scene. So I can add another payload set and reference set and do exactly the same for these other assets. I'm actually going to use group stacks for these as it's a really nice way of grouping nodes when you have multiple of the same node type. So then I can really easily just create new nodes and adjust the parameters all from the top level. So now I have my payload and look loaded into these locations. the next thing I need to do is add some prim paths for the assets to be inherited under from these locations. So in the same way as my class prims, I can use prim create nodes to define the prim paths that are required. I'll add this up here with the others so that it's nice and organized. So I need to have locations for the environment, the props, and characters. And I'm just going to split this into separate locations for the doors and hallway sections, just to keep it more organized as well. And I'll do the same for the props. So a prim path for the gun and one for the turret. And this time I'll make sure to check the prim spec hierarchy, as I want these locations to all be defined. And I'm also going to add a camera location at this point as well. And in the Scene Explorer, now these locations will all be visible, and we can start bringing that information from the classes under each of these, and then referencing in the layout. There's a number of ways to do this, and the method you choose is really dependent on how strong you want these opinions to be. So let's just take a quick look at the USD strength ordering for a sec. So we could use inherits, references, or specializes to bring the data across. Inherits and specializes work in the same way, where they'll copy the hierarchy and properties from, in this case, the class location, and then that connection will remain live. So any changes to the class location will be carried across, unlike with references, where the connection doesn't remain live. The difference between inherits and specializes comes down to their strengths. So we can see inherits hold the strongest opinions after local, and specializes are the weakest. Because of this, I'm going to use specializes here because I may want to make overrides to the reference look, for example, on a per shot basis. So I want these opinions to be able to be overwritten if needed. And in this case, there's really nothing that could get overwritten that I wouldn't want to be. So I can safely use specializes here. If you want to make sure any opinions don't get overwritten, then I'd suggest using inherits. So I'll drop down a USD specialized set node. And in this node, I can specify the path I want to specialize from. So that would be my class. And the locations I want to specialize to, which would be under my geoprim paths that I did a moment ago. I'll just refer back to my file directory where I can see what locations I'll need. So I'm going to want a specialized location for each layout that we have, because I'll then reference the layout on top of those locations. So for the hallway section, I need each of these as a prim path, so I'll add these now. And again, this is the same process for each asset. So I'll just get those nodes set up in the same way. And again, use a group stack to keep them organized. While I'm setting this up, I'll just explain the process and why I'm doing this again, maybe so it's a bit clearer. In this particular sequence, I have the same asset, which is duplicated multiple times to build up the scene. So it makes sense to have my payload and look loaded to a class, which can then be inherited or specialized from. If I just have one asset for the environment, then I could just bring in the assembly file and maybe have a layer for any layout. But with this process, I'm also trying to demonstrate how much is now possible inside Katana itself. So I'm really breaking down these steps. And once I've done that, over in the Scene Explorer, we can now see that there are locations underneath the geoprim paths, as everything has been specialized from the class locations. And if I expand out these, then we can now see the assets in the viewer. So now I have all the building blocks ready to start adding the layout. Each of these locations that I've specialized to needs a layer to specify the layout. Normally this would be done using a sublayer to bring the layout information for all the elements. However, for this scene, I have the layout information as separate layers. So I can bring it in the same way as look files, using USD reference set nodes to specify each geoprim path. and bring in my layout USD files. Again, I'll speed this part up because it is the same process for each location. But you can see as I'm adding these in, the layout and our environment is updating in the viewer. And we can imagine each of these references coming from a different department. So I'll be getting my payloads from modeling, the look from look dev, layout from the layout department. And this is really one of the main strengths of a USD pipeline, as you get small overrides exported rather than entire huge assets. So if the layout for one particular asset needs updating, it's a very small file to write out and very easy to switch over at this stage because the reference file can just be overwritten. And the same goes for the look and animation and any other layers that build up your stage. You do also have the ability to set the layout or make any tweaks inside Katana itself using the USD transform set node. With this node, we could grab any of these locations and transform that geometry to position it wherever we want it to be. The transform can also be placed after the references and it will still be applied because local opinions are the strongest out of all the composition arcs. So we can make any adjustments that might be needed without necessarily having to go back to the layout department and re-exporting that layer. Something I want to come back to just before we move on is the working sets. I mentioned these earlier, but now that we have the environment set up, it might be a bit clearer. So if I enable the payload working set, then you can see all the payloads are unloaded from the scene, and I can now manually choose which ones I want to be loaded. This loading will replace the expansion as a way to load in these assets. You'll see a little white arrow to indicate where the unloaded payloads are, and I can then click these to load them in. Once they're loaded, the arrow will turn black and the background color will change to indicate the load state being used. I'll go into a little more detail on this in a moment. Something to note is that if I collapse this location, the geometry is no longer visible in the viewer, and this is because viewer visibility is not tied to payload loading. So at the moment, it's still being controlled by Scene Explorer expansion. So I personally like to use the viewer visibility working set, so I can have everything collapsed to the payload or component level while still being able to view the scene. You can also shift click any location to load all payloads onto that location. Or highlight multiple locations and click to add or remove them all. These load states reflect the behavior and naming of the USD payload loading rules, and were designed that way to align with USD conventions. If you right click, you'll see these load state options with the color coding. So as well as loading one or all payloads in a hierarchy, you can also use the load none state to remove payloads from a group set to load all. And this is the same for visibility. If you right click, you get these options, so you have a lot of control over what you can or can't see. So now I have my sequence layout all set up, I can start bringing in my shot specific elements like my characters and animated props. So I'm going to go through this workflow for one shot, as the process will be the same for each one, just bringing in the shot specific elements. Before I do this, I'll just add some backdrops to tidy up and organize my node graph. This makes it look a lot nicer, but also means that when my node graph gets bigger, I can navigate to these sections with the J key. So I'll start with one shot, which is shot 350. The first thing I'll bring in is my shot camera. So I'll load that in as reference. underneath the camera prim that I already created. And now we should see the camera in the Scene Explorer. And then the process is fairly similar to my sequence setup in terms of specializing from the classes under the geoprim paths and then referencing the layout, except instead of layout, I'll be bringing in the animation. So if I just jump back to my file browser again, we can see what locations we need to specialize based on the animation included in the shot. So for this shot, I have 8 characters, 7 gun props, and 1 turret prop. So I can refer to this when specializing from my classes. So I'll add a specialized set for each asset, and again, keeping them all organized inside a group stack, and do exactly the same setup as the environment. Adding the class as the specialized path, and then creating new prim paths reflecting the files in my folder. Now I have these, I just need to layer in the animation. So I'll use a reference again for this, exactly the same setup as the layout. So I'll add a reference set and organize them into a group stack. So I'll need a reference set for each character, each prop, and then I'll just be loading in the shot-specific animation file for each one. And I'll jump into the project settings and set the frame range so we can see all of this in the viewer. For this particular shot, there is also an animated door, so I'm going to bring in the animation for that as well. Again, as a reference, as this will override the layout that was referenced above. This is because if 2 opinions have equal strengths, as in this case they're both references, then the order in the node graph does come into play. You can also set which opinion will be stronger by reordering the list. So it's set to prepend by default, which adds it to the front of the list so that it's stronger than any other previous opinions. You also have the option to append, which will add it to the back, so the layout reference will be stronger in this case. You can also delete the value or reset the list completely. The behavior for each of these is explained more in the USD docs. And now we have our shot set up, and we have some really nice speedy playback as I scrub the timeline, because all of this is brought in as native USD data. Something to note is that viewing through USD cameras isn't yet supported, so to do this I can use a UsdToKatana node to bring just the camera across. And I'll bring it to a root world cam location. Now we can see over in the Scene Explorer that this location has been created under the Katana section, and the camera object is here, and it's been removed from the USD side. If you wanted to keep it in USD as well, then you can uncheck the deactivate prims checkbox, but there's no need to do this in this particular case. Now I can view through this camera and see all of the shot elements. So you can see we can have these USD elements and Katana elements all working together within the same scene. This USD to Katana conversion is done to the entire scene at render time. So you also have these parameters available inside render settings nodes under the deferred USD to Katana section. But for things like this camera, in this case, where we want to be able to access and view through it, a USD to Katana node is really useful. While we're looking at and talking about working with Katana elements and USD elements in one scene, I'm going to start bringing in the VDBs for this shot. And I'll do this using the Arnold OpenVDB node. So I'm going to merge this in above my USDToKatana. I'll change the path to volumes/turret VDB because these volumes are for the turret prop. And then I'll navigate to those VDBs which are in my shot folder. Just make this path relative and remove that frame range from the file path. I'll add a density grid and scale it up. And then we should be able to see this volume in the Scene Explorer. And if I expand it out, and we can also see it in the viewer along with our USD geometry. So we really can be working with both of these together. There's no need to have everything in USD or everything in Katana. I'll quickly set up a material for this volume. So I'll merge in a network material create and create a turret volume material and just set up an Arnold standard volume shader. Decrease the density a little and set up the transparency parameters. Then I'm just going to assign the material to the volume. And group these nodes together so they're nice and organized. I have another VDB which can be applied at a sequence level because it's used in a couple of shots. So I'm going to copy this group and set that up now. So I'll just bring in the sequence level VDB and change the location name and the material name and assignments. I can tweak the density and the materials for these VDBs once I start getting some renders running. And these sequence volumes will need to be transformed on a per shot basis. They're actually not visible in this particular shot, so I can use a variable enable group instead of a regular group and set that up correctly once I have all the shots in the scene. So to finish up my shot setup, I may want to prune certain elements that aren't needed. For example, in this shot, the camera's focused in this area of the environment. So on these two hallways and this one door. So I could prune all these other hallways and elements from the shot. To do this, we can set these prims to inactive using a UsdActiveSet. Inactive prims will be left out of the stage composition and traversals, so it's a good workflow for pruning these elements from the scene. Jumping back to the Scene Explorer, we can also set items to be active or inactive using the active working set. However, unlike the node, this working set will only affect the viewer. So if I just disable this node for a sec and do the same but using the working set, you can see the elements are removed from the viewer, but they will still appear in renders. So with these working sets, the viewer visibility, payload and active, you really get a lot of control over which elements are loaded, which are visible, and therefore keep your scene as lightweight as it needs to be for you to work with. You get all these options of how to control these elements, each working differently behind the scenes to give different results. For example, in some cases, the active working set may be more efficient than visibility because it's actually stopping those elements being composed. Again, we can refer back to the USD glossary because all of these are concepts of USD. So you can find more information about all of these terms in that documentation online. So now I have the setup for one shot. I can repeat this process for each of the other shots in my scene. I'll speed this up because the process is the same, as I said, except I'm just bringing in the elements which are specific to each shot. So some shots won't have the gun props or door animation, but the general setup and process is the same. Once that's done, I can plug each of these into a variable switch so that I'll be able to switch the shot with a graph state variable, which I'll quickly set up now. If the cameras for all of the shots have the same naming convention, then when I'm viewing through the camera, it will update as expected when changing shot. If the cameras are named differently, then you'll need to manually choose the camera again from the list, and then use an expression in the render settings to update the render camera for the chosen shot. So that's something to bear in mind. So now I have a nice separate section for each shot-specific setup, and I can of course continue to refine and add other nodes here that might be necessary. For example, I can add my transformations for the sequence VDB to the shots that require it. And while I'm doing that, I can also switch this over to a variable enabled group for the sequence volumes, as it is actually only 2 shots that need them. And here I can also add network material edit nodes to refine any materials. For example, I can tweak my volume materials on a per shot basis. If I wanted to use this for materials brought in with the USD look files, then I'll need to bring them across to Katana first, in the same way that I did the camera. And I can add any other transformations, attribute set, relationship set for any elements and any other refinements that might need to be made at this level. Depending on how you prefer to set up your templates, you could add any shot-specific lighting within these same sections and have the sequence lighting set up here somewhere. However, I prefer to keep the lighting separate, so I'm going to add a sequence gaffer 3 here and have shot-specific lighting in a different section. I won't go into too much detail about the lighting setup of the scene in this video because I want to stay really focused on the USD specific workflows. We do have a lot of content on the Katana Learn page if you would like to watch any tutorials focused more on lighting workflows. I'll add a render settings and bring in the camera so I can start setting off renders while getting all of this lighting set up. You can see I'm using all of the Katana workflows that you may be used to set up these lights. So the lighting tools in the viewer can be used with USD scenes, live rendering and Foresight Plus, so running multiple renders at once, can all be used in combination with the new USD workflows. So again, they don't have to be kept separate. I'm setting up the environment lights, separating them out into each asset section. So my hallway, intersection, and then the door lights. Each section has multiple instances of the same lights, so I'm using template materials, so I can just adjust the lights assigned that material from one place and still make refinements on individual lights where needed. Because these assets are duplicated multiple times to build up the set, I can do exactly the same with the light setup by setting up a rig and then duplicating it and transforming it to fit the other sections. And I'm going to have a similar setup to up here, except for my lights. So for each shot, I'll add gaffer 3s to make overrides to the sequence level lighting where needed. And I can also add any other lights. So for example, character and prop specific lighting. For light linking, you'll need to reference locations from the Katana side. So you can either use a UsdToKatana node to bring those elements across, or a nicer workflow could be to add the location for where the geometry elements will be brought once the deferred UsdToKatana conversion has been done as part of the render process. To do this, you could enable implicit resolvers to be able to see those locations in the Katana Scene Explorer, and just add them to the on or off parameters. So with my character light, I want to turn it on for the char location and off for environment and prop. And then I can disable implicit resolvers again, and I'll just solo this light and set off a render to make sure it's working. And yeah, it's being applied just to the characters. The last thing I want to cover is the USD VariantSet node. This node allows you to choose an existing variant set and a variant option that has come in with a specified location. So for example, I could drag in the class location for my character, and then I have a variant set for the suit color, and I can change this, and because all the characters are specialized from this class location, every character's suit color will be updated. And if I wanted to update the variant for specific shots, I could add the variant set into those shot specific setups as well. I could also set this variant to only affect specific characters by just adding the path to that character here instead of the class. Any variants which are coming through USD nodes can be set using this node, whether they're material variations, geometry, or any other scene variants that might have been baked out. And I could also link these up to a graph state variable so that my scene variations are accessible from the graph state variable dropdown. So I can do this by just setting up a new graph state variable, making sure that I use the exact same names as in the variable set dropdown. And then I can use an expression in the variant field to link this option to the graph state variable. So you can see how you can build up your scene using all of these native USD workflows and combine it with traditional Katana workflows as well. And from here you can continue with all of your usual workflows for your AOV setup or render layer setup, and use the Nuke Bridge in exactly the same way as before to view your renders in the context of a comp. You can also refine the render settings and add things like motion blur or depth of field, all as usual as well. So again, all of those Katana workflows are still the same. And as I mentioned, this is just the beginning for native USD workflows in Katana. There's a lot of exciting development planned for future releases involving both USD and Hydra. And as always, please do visit the Katana Learn page for more information on this, as well as other releases and features.